So this is a problem on bending equation. A beam simply supported and carries UDL of 40 kilonewton per meter. The load on the beam is 40 kilonewton per meter and it is UDL and the beam is simply supported. Okay. Let me write the data. UDL is given in the problem. W is equal to 40 kilonewton per meter. Okay, in terms of Newton per millimeter, it will be 40 Newton per millimeter. Okay. Conversion of kilonewton into Newton is into 1000. Conversion of meter into millimeter is into 1000. 1000 in the numerator and the 1000 in the denominator will get cancelled. Finally, we will get the same value, 40 Newton per millimeter only. Okay. The section of the beam is given. It is rectangular having depth of 500 millimeter. Depth of the beam is given. D is equal to 500. 500 millimeter. If the maximum stress in the material of the beam, maximum bending stress is given 120 Newton per mm square. And the moment of inertia, inertia is also given, that is 7 into 10 power 8 mm raised to 4. Find the span of the beam. We have to find the length of the beam. Okay. So here we have to utilize the bending equation, that is M by I is equal to F by Y. Okay. First we will find the moment, that is M is equal to F by Y into I. Okay. F is given as 120 Newton per mm square. F is given. F is equal to 120 Newton per mm square. Then Y is nothing but distance of extreme fiber from the neutral axis. So for rectangle, this is the neutral axis. So distance of extreme fiber from the neutral axis will be d by 2. D by 2. Therefore, Y is equal to d by 2 is equal to how much you will get? 500 divided by 2, 250 mm. 250 mm. Then I, moment of inertia, it is also given in the problem, 7 into 10 power 8 mm raised to 4. Okay, by this M is equal to F 120, Y is 250 mm into I 7 into 10 power 8. Therefore, M is equal to 20 into 7 into 10 power 8 divided by 250. It is how much? 336 into 10 power 6 Newton millimeter. Newton millimeter. Okay. What is the question here? Here we have to find the span of the beam. Okay. The condition of the beam is given, that is, it is simply supported. Okay. The beam is simply supported. loading condition on the beam is also given. That is 40 kilonewton per meter. UDL is applied on the simply supported beam. Correct? Due to that UDL, just now we came to know the moment, the total moment on the beam. Correct? We will utilize all this data and we can find the length of the beam. Okay? It's a simply supported beam carrying UDL. Intensity of UDL is how much? 40 Newton per millimeter. L that only we have to find now. Now for simply supported beam carrying UDL, the formula for moment is WL square by 8. Moment is known, that is 336 into 10 power 6 is equal to W, intensity of the UDL. It is 40 Newton per millimeter into L square divided by 8. By this we can solve for length of the beam. Into 8 divided by 40 and root of answer. Okay, so L is 8197.56 by 6 millimeter, or in terms of meter, it is L is equal to, it will be how much? 8.197 meter. Okay, by this we got the answer, length of the beam. Okay, so to this solution is over, and in the next video we will solve one more problem. Thank you.